Hello class, welcome to lesson 11.3, which is all about simplifying rational expressions. By the end of this lesson, you should be able to identify values that are excluded from the domain of a rational expression, as well as simplify rational expressions. Let's take a look at our first example. We have 5x over x squared minus 81. I forgot to include the directions here, but I want us to find the excluded values. So remember we talked about excluded values in the last section where they were any number that made the denominator equal to 0. Okay, so if we have x squared minus 81, how can we split that up? What numbers will make our denominator 0? So remember, when you have x squared minus a number, and if that number is a perfect square, then again, this is a perfect square. So we can say that we have an x and an x. And then what number times itself gives us 81? We have a 9. And when it's in the form x squared minus a number, you do 1 plus 1 minus. So our excluded values, we know that if we were working with this expression, x cannot equal positive 9 or negative 9. So I'm going to say plus or minus 9. If you wanted to write it out like this, that is also fine. Alright, let's take a look at our next expression. We have 3a minus 2 over a squared plus 6a plus 8. So again, let's take our denominator. Let's break it up. What numbers add to 6 and multiply to 8? So add to 6, multiply to 8. If I do 4 and 2, I know that they will add to 6 and multiply to 8, but they have to be positive. And we have our a. So our excluded values, if we wanted to make our denominator 0, we could plug a negative 4 in over here. So we could say a cannot equal negative 4. Or you could say a cannot equal negative 2. Alright, so there are your excluded values. You'll have to work on your factoring again and make sure that you have that skill down. If you don't quite remember that, please be sure to ask for help. I want you to take a minute and try to find the excluded values of x squared plus 1 over x squared minus 5x plus 6. Okay, hopefully you found out that the excluded values were 2 and 3. If you did not get that answer and you have a question why not, please be sure to ask or rewind and watch the video. That example again to see if that helps. Example 2, find the height of the cylinder that has a volume of 710 cubic inches and a diameter of 18 inches. So if we want, we can create a proportion. We know that we have a volume. We have a diameter, so we can use an equation with our, if we're trying to find the height, we can use the equation of our circle. So you can set it up with volume equals pi r squared. And then if we look at our information, we can just plug our numbers in. We know our volume of this cylinder is 710, so we put that on top. And then down below we have pi. Then we have a diameter of 18. That means our radius is 9. And then we square that. So we have 710 divided by 9 squared. That's 81 pi. So 710 divided by 81 pi. Remember, if you're plugging this into a calculator, you need to use parentheses around 81 pi. Otherwise, you're going to get 710 divided by 81 times pi, which is not the same answer. So hopefully you ended up with approximately 2.8 inches for a height of that cylinder. Okay, try setting this problem up the same way, where you have your volume equals pi, or volume over pi r squared. See what you end up with. Hopefully you ended up with 3.4 inches. If not, again, ask for help. Now let's look at simplifying rational expressions. If we have a, b, and c, and they're polynomials where a does not equal 0 and c does not equal 0, what this would look like is if we have b times a over c times a, that's the same, ultimately, as b over c. Makes sense? Because our a's would cancel. So if we look over here, we have a 3x minus 9 over a 4x minus 12. Well, there is a number that we can pull out of each of these. If we look at the top, we can pull out a 3, and then we're left with 3 times the quantity of x minus 3. And down below, we can pull out a 4, and we're left with 4 times the quantity of x minus 3. Our x minus 3's cancel, and we're left with 3/4. Okay, so that's what we're going to look at in our next example. We want to know which expression is equivalent to 32x to the 5th y to the 2nd over 4xy to the 7th. So the way that I approach this is I kind of piece it up into the different variables we have. So first I look at our whole numbers. We have a 32 over 4, sorry, not a 2, 32 over 4, and I think, okay, 32 over 4, 32 divided by 4, that's 8. So that means I should have a number 8 on top, because it's not 1/8, it's 8. That means I can get rid of answer D, because that has a 24. Alright, so I have an 8. And then I look, I have my x's. I have an x to the 5th over an x. And I know that when you're dividing powers, you subtract them. So I have an x to the 5th over x to the 1st. And that ends up being x to the 4th on top, because it's where my bigger number is. So I have 8x to the 4th. I can look and I see that letter C has an x to the 6th, so I can get rid of that. And letter A has an x to the 5th, so I can get rid of that. So I'm left with only one answer left, but let's just make sure that it's the right one. I have a y squared over a y to the 7th. 2 minus 7 gives me -5. Our biggest power is on the bottom, so we're going to have a y to the 5th on the bottom. Does that match letter B? Yes. So we know that the answer, the most simplified way to write this expression, is 8x to the 4th over y to the 5th. Alright, take a moment and see if you can find which expression is equivalent to 60, a to the 3rd power, b to the 2nd, over 18a times b cubed. Hopefully, as you simplified it, you ended up with 10a to the 2nd over 3b. If not, be sure to ask or rewind and watch the last example again. Example 4, simplify each rational expression. State the excluded values of the variables. So we're going to take the last example that we did where we were simplifying, and then we're also going to take the excluded values and add them together. So we have n plus 3 over n squared plus 10n plus 21. So my first step should be, can I factor this? Okay, do I have two numbers that add to 10 and multiply to 21? I know that 7 and 3 will get me there, and I know I'm going to have to add both positives. So n plus 7 times quantity of n plus 3 is going to be the same thing as my denominator. So now if I look, I have an n plus 3 over n plus 7 times n plus 3. And we had just talked about how if you have the same thing on the top as the bottom, you can cancel them. So I now have a 1 over n plus 7. So this is my simplified rational expression. And now looking at my simplified rational expression, what are my excluded values? What number can n not be? I cannot have n equal to a -7, because if I do -7 plus 7, I end up with a 0 in the denominator. Okay, so my excluded value is negative 7. One hint I'm going to give you guys, when you are doing problems that look like these, chances are, if you have something written alone like this n plus 3, whether it's the top or the bottom, the other part that you have to factor is most likely going to have that as one of the factors, okay? So something to kind of keep your eyes out for. Not always, but most of the time. Okay, so now let's look at our y squared plus 9y minus 10 over 2y plus 20. So when I look at these, I see the top where I know I want to factor, and then I see the bottom where, it's a number times a variable plus a number. And I see that the two numbers have something in common, so I know I need to pull something out there as well. So let's start there because that's an easy one to pull out. A 2 and 20, what do they have in common? They have a 2. So we can make that 2 times y plus 10. Okay, so this is now our denominator. And now that I have a single quantity like this, I have a feeling that I'm going to find that factor up top. Okay? So I'm going to put my y's down, and then I need two numbers that multiply to negative 10 and add to positive 9. So multiply to negative 10 and add to positive 9. Okay, so what factors of 10 can add to a 9? If we use a 10 and a 1, and if we do, we have a positive 9, so our bigger number has to be positive. Our smaller number can be negative. And then I have a y plus 10 times quantity of y minus 1. I'm going to rewrite this so that way it's a bit clearer. Alright, so that's what it looks like so far. Am I done with it? Not quite, because I have a y plus 10 both in the numerator and the denominator. So I can cross those out, and I am left with y minus 1 over 2. Now, that is as simplified as my answer can be, and I want to look for excluded values. Any excluded values here? If we look back, we have no excluded values for our simplified, but if we went back here, what number would make it an excluded value? Y cannot equal negative 10 if we were up there. Okay? Take a minute and see if you can simplify 5w minus 10 over w squared plus 6w minus 16, and then state the excluded values of w. Alright, hopefully you ended up with 5 over w plus 8, and then excluded values of a positive 2 and a negative 8. If not, ask questions. Let's look at example 5. We want to simplify the expression and state the excluded values. Okay. So again, I look at the top and I see that it's a number times x plus a number, and there's an easier way to write that. I can pull a 12 out, so then I'm left with x plus, how many times does 12 go into 36? 3. Okay, so that's my new numerator. Now let's see if we can figure out what our new denominator is. I have an x, and I have an x, and then I have negative x minus 12. So what numbers multiply to a negative 12 and add to a negative 1? Well, 4 and 3 are right next to each other, so that's how I'm going to get them to add to a 1. But which one has to be positive, which has to be negative? Since our 1 is negative, that means our bigger number has to be negative, and our smaller number has to be positive. So I can rewrite this x minus 4, x plus 3. And sometimes you're going to end up with a situation. I'm going to go off off from the problem for just a minute, and I want to explain something. So what if down here we had ended up with an x minus 3, but up top we had that x plus 3? One thing that you can do is you can always pull out, let's see, if this was negative x minus 3. So if you have something that looks like the complete opposite of what you have up top, so we have positive x positive 3, down here if we had a negative x negative 3, remember this isn't the problem we're looking at, I'm just speaking hypothetically. Remember, you can always pull out a negative 1, so that way those would match and you could cancel one on top and one on bottom, okay? So remember, you can do that. You are allowed to do that. It's been a while since we've talked about pulling out a negative 1 in order to make things cancel. So now, going back to our problem, we have 12 times quantity of x plus 3 over x quantity of x minus 4 times quantity x plus 3. We have an x plus 3 and an x plus 3, so I can get rid of those. And now I'm left with a 12 on top and an x minus 4 on bottom. This is as simplified as I can get. Some of you might ask, but can't we cancel or reduce this 12 and this 4? No, you can't. When you're adding or subtracting in the numerator, you can, or in the denominator, you cannot just separate. You cannot just separate these. Right? They are one number. So this is as simplified as it can be. And now we want to state the excluded values. So what numbers can x not equal? Can't equal a positive 4. Because if we do a positive 4, 4 minus 4, that's going to give us 0 in the denominator. And we do not divide by 0. Take a minute and see if you can figure out the excluded values and simplify. Okay, hopefully you ended up with negative 7 plus x over 5, and then found out that x cannot equal 7. I want to jump back for just a minute. I forgot to mention, okay, so going back here, our excluded values, we know x can't equal 4, but x also cannot equal a negative 3. You do not get your excluded values from your most simplified. You get your excluded values when you have them written as the quantity times the quantity once it's factored. Look for excluded values from your factored form. Okay. All right, our last example, we want to find the zeros of the function. Okay, we want to find the zeros of the function. So before we were talking about finding the excluded values, and that meant we needed a 0 on bottom because that would make our function undefined. But right now, we want to find the zeros of the function. We want to know, where does this whole thing equal 0? So how do you guys think we're going to get a 0 for a function? We're going to need a 0 in our numerator, because 0 divided by any number equals 0. So 0 divided by any number equals 0. That means we need to get our numerator to equal 0. So let's start by factoring our numerator. We have an x squared plus 2x minus 15. So what multiplies to a negative 15 and adds to a positive 2? Okay, so what multiplies to 15 and adds to 2? We have a 5 and a 3. And then which one has to be positive and which has to be negative? In order to get a positive 2, I need my 5 to be positive and my 3 to be negative. And then I put my x's in. And this is my numerator. What numbers would make this equal 0 in the top? If I plug a negative 5 in, I have negative 5 plus 5. That's a 0. 0 times, if we did negative 5 minus 3, that's negative 8. But negative 8 times 0 is still 0, so that one works. And then if I plug a positive 3, I have 3 plus 5, so that's 8, times 3 minus 3, which is 0, so 8 times 0 0, we know that one works too. So the zeros of our function are when x equals -5 and x equals 3. That's all you have to do when you want to find your zeros. You don't have to do anything with the denominator. You only have to look at what makes the numerator 0. Alright, now find the zeros of f of x when f of x equals x squared minus x minus 20 over x plus 4. Hopefully you ended up seeing that your 0 occurs when you have x equal to 5. If you have any questions on how to find these answers, please be sure to ask either myself or a friend. We'd be more than happy to help. I hope you guys have a fantastic night.